I have to restart something. Okay, great. All right. Welcome to another live stream of Wolfram Language Design. This is our incremental language design meeting, and we have a variety of topics. So first we are in the treetops. Okay.
Yeah. So I think from our previous couple of discussions, we generally like the functionality here, but we're having a little bit of trouble with the naming and just consistency with the other tree functions in terms of concept and
right
design.
So let's review again what these do. And are they runnable in the prototype build or anything else?
No.
Okay, so you have to demo them or send me somewhere where I can remember.
There are ref pages.
Okay. Okay, so let me try to remember what these were, and let me try and describe them in my words. So AncestorTree is the things that are above a given set of nodes in a tree. This is the common ancestry of those nodes. Is that correct?
Yep.
Well, hold on. It's the union, not the intersection. So it's not the common ancestor.
Okay. It's the all ancestors.
Yes.
I mean, common ancestor is another concept that might be useful. Correct?
I think you can do that just with looking at the positions as lists. Like you just want.
I see. You want to look at the lists where they agree.
Yeah.
But I mean, one possible name just for that concept would be common ancestor tree. What would
that do? It would return this sort of the tree up until, I mean, basically it would return the in order for it basically would return a path tree up until the split.
Is it a path tree?
Well, if it's the ancestors and it's the common ancestors, then it has to be a path, doesn't it? Unless you're including branches that don't lead to these nodes also.
Oh, you're right. It would have to be a path. Yeah, I mean.
So say you give two positions, you'd have a common ancestor and then two branches.
Well,
right. I mean, that doesn't return a tree. That returns like a particular node. I guess a node is a tree of some kind, but yeah. I guess that would be the common ancestor tree function. Would be the tree whose root is the lowest common ancestor.
Mm-hmm.
I see.
It's like the greatest common ancestor tree or something. It's sort of like the GCD or something.
Yes. I just want a tree just to see something. Okay, so for example, of 13 and 19, we would get up to the 20 here. We would get from 29.
Right, so 29 would be the least common ancestor of those two. And you could give that as a tree, and what AncestorTree is doing the same thing, but all the way up to the root.
So wait a minute, AncestorTree is giving the whole thing up to the 9. So it's giving a path graph down to this. Is that right?
And then it'll split because 13 and 19 are on different branches.
Will it also include like the 1, for example?
No.
Which is below the 13. Okay. Oh, because it's not an ancestor.
So
right.
I think it's helpful to compare this with tree delete and delete. So delete, you give it positions and you get rid of that position and everything below it. But this is you give it some positions and you keep that position and everything above it.
Well, I'm warming to the name AncestorTree. What was my objection to it last time?
That it sounded genealogical. But I think lots of things have genealogical terminology in trees.
And it's the correct genealogical concept.
Yes.
All right, fine.
So I don't think we discussed this suggestion. What do you think of the name tree keep? Because the other functions in this family are tree and then a verb is one point. And then the other point is that this is a well-defined operation on expressions, not just trees. So it might be good to have a name that works in both cases.
What would it do in
Reminds me of
expressions?
the keep of a castle. That's about all I know about keeps. I can't remember what it is. It's part of a castle.
In the sense of keeping these positions rather than deleting them.
Right, and what's it going to do though with the leaves? Is it going to turn them to null in the expression case?
No, it'll just delete the arguments.
Oh, I see. Okay.
What is the operation for an expression?
It would be, so like if you said position 1, then you would get rid of everything on other branches from position 1, and you would get rid of position 1's children.
So wait, how is this different from? So it's basically the complement of delete. So with delete, you'd say, right, with delete, you'd say a position and it would get rid of it. This, you say a position, it gets rid of everything but that position.
I've never used this function. I've never wanted to use this function.
Right, so delete gets rid of the position and its descendants and doesn't affect other branches. AncestorTree keeps the position, gets rid of its descendants, and gets rid of other branches.
Yeah, I mean, I'm not sure. I mean, I sort of agree that I'm not sure how useful the expression version would be, but
I don't see it as being that
Yeah.
useful. I think that, I mean, I haven't missed it in a third of a century, as far as I know. Anybody else want to disagree with that? Okay. I think AncestorTree is okay. All right, what's treetop now? Treetop is level down to a certain level, right? It's essentially a tree. It's the analog of shallow for a tree.
Yep.
And again, it's the branches and the trunk. It's not the tree top.
What do you mean?
That the tree top. I mean, if we're going botanical,
Oh, for God's
tree
sake!
top is where the leaves
right.
are, and this is the opposite.
That's horrifying.
And you had suggested last time potentially calling treetop root tree and giving it a one argument form that just gives the root.
Yes. I think that's reasonable. I mean, okay, what's the difference in ancestor tree and root tree? Those are understandably different. An ancestor, you have to give the thing that it is, that it is ancestoring, if you understand what I'm saying.
A position.
Okay. Can I ask a question? When we have a spanning tree for a graph, do we have a way of getting it out as a tree?
You can convert it to a tree using graph tree.
I see. Okay. Sort of unfortunate that we have a what is it called? Fine spanning tree? Yes. Sort of unfortunate that doesn't return a tree.
For new functions that return tree graphs after we've started the trees project, we've started putting tree graph in the name, like dominator tree graph.
Is there a reason to have that function, not just dominator tree, and then you can use graph to get the graph of it?
Because you more often want it as a graph.
Yeah, it like lives in the graph world. Be kind of
well, but in particular, you don't want a tree typically. You typically want a subpart of the graph. And I think the same is true here.
And also
change this
also
documentation.
Tree graphs and trees don't perfectly round trip.
I see.
Find a spanning tree graph that minimizes the total distance between. You probably should change this documentation now. And possibly it should have some other argument that allows it, or at least it should have a good example that quickly shows how to turn it into an actual tree. Although I think in this case, you're more often wanting to kind of prune a graph to a subgraph, so to speak, than you are to make a genuine tree.
Mm-hmm.
Okay, I'm happy with ancestor tree and root tree.
Okay.
Okay, are we on to the next topic?
Yep. We have Eduardo and Gosha from Probability and Statistics here. We had them look over a handful of promising, or at least potentially interesting things from the function repository, and these were a handful of things they pointed out as being potentially useful and reasonably implementable.
Is this accumulate, but it's the mean?
Yeah. That one doesn't really float my boat tremendously.
Yeah, because you can always just do accumulate divided by range of length of blah, blah, blah also.
Yeah, but I haven't needed to do this very often. I mean, it's kind of like you're either accumulating or you're somehow taking the mean. But this accumulated mean, I don't see very often. Anybody, am I missing something there? Somebody speak up, please.
I can imagine it being something you want for
Who
time
picked-
series.
Yeah, who picked this out? Gosha, Eduardo, can you speak, please?
Well, these are the suggestions from the function repository.
No, I
so-
know that, but I mean, you picked them out. So what was your reason for picking this
The
one?
reason for it is that this kind of what I call running, analytics. So which is kind of going through the series or through the time series are, used in, for example, finance or financial analytics. So I run into the running, what I call running maximum or running minimum. And so running mean is very close to this idea. So my thinking here is that, this could potentially be a part of what we call the time series processing, functionality, where we can have this kind of an idea that you specify a function and then you have a resulting time series, which is, so the running minimum or the running mean or the running maximum. And so that could potentially be, I think, part of, time series processing.
Okay, but what you're highlighting is this notion of something which I've certainly wanted, which is a running really what this is some kind of running map.
Correct.
Of max, comma list, for example.
Right, and the thing is here that we don't have a fixed length window, so it's not really the windowing what we have with the moving map windowing operation when the window has a constant kind of length. But here we see that the window is right; it's anchored at the beginning, and it's just kind of extending. What's the relationship
between this and fold?
I think that fold could do this with supplied. Normally in fold, the second argument of the operation is just the next element of the list. But this is like fold, but you're taking the whole prefix of the list, not just the next element.
Although also to be clear that oftentimes that you can implement these things more efficiently with fold anyway, and not very difficult. I mean, like the max there will work with fold, and it'll probably be more efficient than if you do it with the supplied way.
Sure. Well, mean, for example, is one where you just want the whole list. You don't want to have.
Well, but if you have supplied though, you could ask for the index, and you multiply by the index -1, add the new element, and then divide by the index, right? And that will get you the mean.
Right. So you don't have to recompute the whole thing in quadratic time.
Or yeah, and what I was saying is supplied could have a key that just gives the whole list, so you don't have to.
Sure, but you don't want to do that because you I mean, look, okay, the function running. I don't know if it's running map or something like that. Something like this is something I've definitely wanted. That is, always show me the maximum so far. Did we put in position max? What is the thing? Find me the position of the maximum.
Position largest.
No, that's not the position of the maximum.
So it would be
take largest with an index.
Exactly.
Yeah.
In what sense?
So it's take largest of list arrow quotes index.
We should just record this because this question has come up more than several times now.
How do we do it?
Comma
Comma
one.
one, comma one, or comma two.
Why doesn't that
It's
just
take
work?
largest.
Okay, but then
Well, maybe
Look.
maximal by, because we also have maximal. Oh no, it's only
that's
maximal
not the
by,
right
never
thing.
mind.
Oh yeah, that is that. Look, I've wanted this function so many times. This position of the max.
Yes, and we have discussed this several times. The problem is that what happens if the max is repeated? So we are forced to have a list.
That's like commonest, right?
And that's why we ended up with a take version.
Yeah, but
Take
this
will always have
index
some
thing is.
arbitrary ordering, or
I mean, if we said position largest of this, look, I mean, it's the same issue with this commonest, right?
Yes.
and with position. If you do position of max, it returns a list.
Sure. I mean, the number of times I've had in my code, position of list, comma max of list. I kind of think that we should have something like position largest.
Should it not be largest position or something?
There is
Oh,
a
because that-
position largest function in the function repository.
Yeah, it was like the first thing submitted.
Mhm.
I think it should be position largest, and I think it should be basically equivalent to this thing with the index there.
Why is it called largest instead of max? Is it because it uses order instead of just numbers? Or does max work with order? I'm not actually sure.
Standard
No,
is suggesting max position, which is the thing that I would immediately think of to call it. The problem is that max position might be something quite different. It might be the, if you have an expression, it's the maximum value of the index, not the position of the maximum.
Wait, as in length. That's a kind of weird.
No, that's weird. Okay, forget that. Forget that comment. Look, we've wanted this a million times. This thing about, so we need to, and I take the point that it's got to return a list because there may be, like with commonest, max, position largest. I mean, we didn't call it take max because we did want to use order because it isn't necessarily linearly, for example, it might be strings or something where we're using ordering of strings. Although I admit that I kind of favor position largest.
We also have maximal by, which is similar, but doesn't have indexing.
So this is a family. So it would have to be position largest, smallest, and potentially the byes.
Yes, I think so. I don't think that's terrible. Okay, but let's come back to running. I like these, and I think we should try and do them. But let's talk about running map.
So, John McClune suggested something similar recently. He has accumulate apply in the Wolfram function repo.
Ian, you've got to send this in some different form. This is not going to be useful here. If I copy this, it's just going to look like garbage. What is this? Ian, hello.
So that parafold is the variant of fold that I was saying, where it takes the entire list up to that point as the second argument.
Okay. Like nest while can do, it can take a gulp size, so to speak.
Mm-hmm.
Right.
Similar to that.
Okay. Take position.
We have a fold while now.
Yes, we do.
Well, so
I
the
know
difference
that's
with the while functions is those are like giving the previous results, and this is giving the previous elements of the input.
Okay. Okay, but down on our live stream is suggesting take position by. I don't understand that one. Oh, I see. That's an alternative to the.
Yeah, instead of having to say largest or smallest.
Why does that make sense? Position largest. I prefer position largest. I think that's what it's saying. I want to talk about running map though. So what that's doing is it's always giving, for example, the maximum so far will be running map of max comma list. Is that well defined? Let's see, a running map.
Right. For a lot of functions, F, you would want a custom implementation within running map.
Right? I know, but what is the general form of running map? So running map of F comma list, F comma ABC would be, right, it would be F of A, F of.
Probably A in a list, right?
Yeah. I see. It's just F of A, F of BC, F of ABC.
No.
The second one is wrong.
Sorry, AB. Okay, that's what it is. So it's a sort of triangular map.
Right.
And the whole point is that there are many forms of F for which this can be done much more efficiently.
Ian also posted a function repository function called accumulate apply. That might be the same thing as parafold.
Yeah, can you say please?
It's more like running map, because so with map you have a one argument function, right? And so you're having F of list A, F of list AB. This is an apply version.
Well, wait a minute. Applied to what? I mean,
This is like running apply, and what you have on the left is like running map. And parafold is the same concept but applied to fold.
Okay, so hold on. Running apply, I see. So this is just a question of whether it provides the list or whether it provides the individual values, which is only really relevant for a flat function, probably. You see what I'm saying?
Yeah.
For numeric cases, you would probably want the list to avoid unpacking.
Yes, but you might want something. I mean, the question is, for what values of F can running map do something much more efficient? So it's some kind of, it's not quite an idempotence thing, but it's some kind of property of F, right? That allows you to add in another one, to fold in another element.
For example, in Max, it will be able to reuse the previous value.
Well, I know.
And like Christopher was saying, mean can do it, but you have to keep the count as well. Right.
Right. But the basic point is there's a case where you don't have to recompute, because the new value, what properties does the function have to have so that the new value with it's kind of a function that folds in its next element, where it's essentially varargsness comes from folding. Is that right?
I think it's just functions that you could write with fold can be written with fold, is kind of what you're saying.
Yes, but once you can write it with fold, there's a much more efficient way to compute this running map than.
Often, yes.
Yeah.
I put some code for running map in the chat in terms of parafold.
Okay. I wish we had a better way to do this chat. I wish we could use our own chat thing where you don't end up with these stupid things here. But yeah. I don't understand. What the heck's that X doing there?
I didn't have the 2-argument form of parafold.
No, but I mean, we don't want that, right? I mean,
Yeah,
we
yeah.
agree that that's just this.
Mhm. So I guess this is showing what I was saying. Map is a 1-argument. Fold is a 2-argument.
What?
The operator F in fold takes 2 arguments. The operator
Yes, obviously.
takes 1.
Yes, obviously. I mean, okay. I think running map is a useful function. I think it will be used with max a whole lot. I think it's what other functions will be? I mean, I think mean is what Sandra is commenting on here. Sandra's commenting the word running kind of suggests a little bit more like the moving map, but I don't think so. I mean, it's the running maximum or something, you would normally say, right? It's the maximum so far.
I can imagine using it with the select operation. Find all the people who took the survey that are under 30. You know,
and how would that work?
Show the time, you know, show it over time. How many people?
I see.
Yeah.
So you're accumulating a selection
right.
of. Okay, so do we like the name running map for that idea? So this would be running map of select, you know, hash less than whatever, hash age less than 30 or something. Right? Onto the data. Right? Or maybe it's even here, we would even say length. Actually, that wouldn't be that, it would be length.
Do you like that better than accumulated or cumulative?
I don't think it is accumulative. I mean, it isn't that. That isn't the concept. Cumulative, accumulate. Well, or is it?
Accumulate is like running map of total.
Yes.
Right.
Okay, other names for this. Cumulative map.
What about cumulative map? Cumulative, yeah.
Yeah.
Because you're accumulating,
I like
and
that.
you know, like what we have in a probability, we have cumulative probability function, which is having similar effect that it's increasing. And so it's accumulating the probabilities up to that point. So if you have cumulative map, maybe just accumulating the maximum up to this point or accumulates the minimum.
Let me tell you a
like
concern that I have about this name, about the map part of this. This thing here is being fed the whole list. That's not what happens in map. In other words, if I say map of this, I'm doing that. Do you get what I'm saying?
Yep.
It's like mapping at the part numbers instead of taking from the list and then mapping on that.
I didn't understand that comment, but it's basically taking
versus part.
What?
So this is more a take, actually.
Mm-hmm. It's like regular map. You could think of it as you're applying to the parts. So like part 1, part 2, part 3. Whereas with this, you're mapping to take, comma 1, take, comma 2, take,
But
comma.
Doesn't moving map do this? And we call that map.
A moving map would be taking with it part, comma, span, if we're thinking about it like this.
Yeah, but the point is what
But it's still it's still acting on the list.
yes,
It's
that's
not,
right.
Yeah.
Let's try and do this as cumulative map.
But you could think about cumulative in a sense that it cumulates the arguments.
Right.
Yeah, but either way, I mean, I think I have been confused by moving map taking a list, which it does, right? Moving map.
Yes.
So,
I mean, I think the thing is, oftentimes when you use moving map, you actually want block map.
why is that 2? Why is it giving lists of 3 elements there?
Because it's range 2.
What does that mean? What do you mean it's range 2?
Look at if you look at the documentation, the third argument has a very complicated specification. Basically, you can tell it things like what it's meant for is if you give it a time series and you want to be able to say something like average the data that's one day radius from this point. And is that point in the center? Is it on the left edge? Is it on the right edge? How are the windows overlapping, etc.? Block map is the like straightforward map of partition function.
Okay. I think we should have cumulative map.
You can also specify this third argument to take the elements.
What do you mean?
When you do quantity of 1 comma.
Wait. What are we talking about moving map here, or what are we talking about? Gosh, what are we talking about here? You're saying in moving map, you can
So in the moving map, you can take the events. I'm talking about moving map.
Okay.
You can specify the events, but this is designed for the length of the window, not for the number of elements, because you can have, you know, irregularly sampled, you know, time series. You want to really, for example, go over a week. So it's your weekly, you know, averages or something. So that's why it's the design itself takes the length of the window, not the number of elements, but there is a way to specify it through the quantity events, basically, to take the fixed amount. But then the length, of course, will be irrelevant. So so this in this way. That's what I was
saying. But the basic point is moving map has an implicit, can deal with an X coordinate, so to speak, and is taking chunks based on the X coordinate, even though the X coordinate in the case of a list is purely implicit. Is that right? I mean, I don't understand why it doesn't, if you've just given a list there, not a time series, yes. I don't really see why it doesn't just take the elements as being 1, 2, 3, 4, etc.
What?
Do you see what I'm saying?
Also, if you give a list to the moving map, it treat it as a temporal data.
But that's crazy, right? I mean, it doesn't have time marks.
What if you give it XY pairs? Right, so I know if you give it XY pairs right now, it treats the X's as the time.
I think this is yet another example of where, like, this temporal data thing, which I sincerely hope time series is getting worked on. It is, isn't it? Gosha. Time series.
Yes, it is.
I'm sorry, because I mean, so I'm saying temporal data, but it's time series. You know, if you think about single list, it converts to the time series because it's a single path, and then it indexed by integers. So we kind of know that all the elements in the list are equally spaced in that way. So that's all. That's kind of how this is understood if you give a list to moving map.
Okay, but I don't understand why moving map with comma 1 gives 2 elements here. Why isn't that kind of in the units of?
Because the distance, because it's inclusive, so you need.
So I think what Gosia is saying is that this is the width of a window.
When you have this.
So these elements are assumed to be separated by 1.
So you're looking from your point into the left and to the right.
I see. So basically you landed on the comma and you're saying how far do you go away from the comma? Is that right? Well, the moving map
I think really it's you landed on the center of say element 2, And if you imagine a window of size of width 1 on top of element 2, the edge of that window will touch, elements 1 and 3. And because it's inclusive, then
it's only
Except
right
that
inclusive.
comma 1 is only going to the left here, or to the right.
To the right. It's only right inclusive.
I think this is a bit confused. I think this deserves investigation, but not.
You're right. So this is left open, right closed. So so the question is, where is your window placed? And you also have a control over, how you kind of place the window, right? So that's the window position WPOS, right? So you can, whether you want to have it in a center and then you look to the left, to the right, or you place on the left end of your window and then you just look forward. So you look to the right, for example.
I have to say, to be critical.
So in this
here,
case, when you have A, B, C, Ds,
Look, I'm sorry, but in this case, I've got to be critical here. This is crazy. The very first example shows a 2 here, and yet the things are in clumps of 3. So unless you explain in that example what on earth it means to say a window of length 2 when there are 3 elements in it, I don't get it.
But I think I do get it. So the first window of length
but
2,
then the second thing, it's exactly the 3 element.
I know, but why did the first one do what it did? Because it says over a window of length 2, and yet I see 3 elements there.
because the window goes from x1 to x3, right? So the left border of the window is x1. The right border of the window is x3.
There needs to be more explanation in this documentation. Gosha, you can see that, right? I mean, this isn't working. By the time it says a window of length 2, and there are 3 elements there, we have to discuss it for 5 minutes.
Right. The note,
Something is wrong.
5th note from the bottom, window specification size or size is equivalent to. I think that's the.
Perhaps
thing,
in some
right?
obscure sense, when the automatic means this kind of thing, I don't even understand what the automatic means. Gosha, can you explain it? I mean, this may not be your functionality. I don't know. Do you not know this functionality particularly well?
But that's what Jose says. It's the length, and so the only thing that maybe it's confusing here because you're looking at the list, and so you don't really understand from looking at the list how we compute the length. So I think maybe the improvement here is to to introduce the time series with the unit distance between the values and for the time step, and then you can kind of see how the windows are built, because each window of length 2 will have 3 elements in it, right? So you go from from x1 to x2 is length,
I get
it's
it
a step
now.
1,
Maybe-
from x2 to x3 it's step 2. So the length 2 would have the 3 elements in the window.
I understand now.
Maybe you should say width 2, because length sounds like the length of the list.
Yeah, that's much better. Right? If you change that language to say,
I see that. Yes.
and then window specification with the size up above
Yes.
it. Okay, all right. So I think we all understand now. Width 2 means the distance from the position specification of the first thing to the position specification of the last thing is 2. But that just has to be better explained. Okay, we're off that topic. So I think cumulative map is a good name for this thing. Let's try to investigate implementing it. Okay, anything further to say about this? Together with position largest, position smallest, etc. Make sense? Any objections? Okay, let's move on. Okay, bin lists by. I mean, this tends to me to seem like it makes sense. I mean, bin lists by. Yes, I mean, this obviously makes sense. Because ordinarily when we say bin lists, I mean, I hope we don't have to, and I don't think we are, introducing sort of a by version of every function. I don't think that we are. I'm not too worried about that.
Could
seems
this
like a
also
good
be
thing.
introduced as in the arguments of bin lists? Like I think there's some examples down there where you have a rule or something.
Where? What?
Well, I'm not sure if this is a proposal or what, but like bin lists of data arrow string length. Maybe you could do that instead of having a by function.
Yeah, I think that was the central question is this sufficiently important to have a standalone function, or does it make sense to be an extension of existing
I think it should be its own function. I think the by family is easy to remember.
Okay. Yeah. I generally don't love the arrow notation to change functionality there.
Yeah, I think that's a a corner case one.
Okay.
We are really these are Sander functions, and Sander is applauding his functions as he should. Let's see. What is the second? That is the bin specification. Oh boy, what do we do with the structure of the arguments here? Do you understand my question?
Yes. So what do we do with take largest and take largest by in that front?
Whoops.
So we inserted the function second. So there is the same question with respect to the
yes,
end.
Yes. Mm-hmm. Right, because the by form, by the time you're using by, you have a function.
Yes.
And is there a default? Let's see. Does take largest by have a operator form?
Yes, with two
yes,
arguments.
It does. Does bin lists have an operator form? Probably not. No, it can't. What is the is there a 2-argument version of bin lists by? Is that a meaningful thing? Is there a okay, hold on. Is there a counts by?
Are we looking at a 2-argument form? This would be more like group by, wouldn't it?
Yeah.
Yeah, I mean, I would think that it being by a by function would potentially be at odds as having a bin specification, because they're kind of two different approaches to the binning process, right? That when we have bin specifications that say I want n bins or I want bins of length y, it's implicitly changing the function that collects them into bins.
It's changing. I mean, this is, you take things like the strings here and you are binning them. Actually, what is the relationship between this and group by?
This is the list form instead of the association form. But since you don't have the keys, it needs to be dense. Right? You need to include all those empty lists in this example.
I see, which is useful.
It's useful, yeah. You need the 1 and the 10 in the inputs, and you need the empty list in the outputs because you don't have keys. Group by has keys, so it can be, you don't need to specify those inputs.
Yes.
Yeah, and it can be sparse. Yeah.
Okay. Well, I think makes sense. Let's investigate, try and implement. Makes sense?
Yep.
Objections? Okay.
So this last one is just a note because it's in related functionality, but we have the old ANOVA package. There's functionality there that would be potentially useful. It's not really a one-off function repo, or I mean, my understanding from talking a little bit with Gosha and getting a little feedback from Gosha and Eduardo is that it's not a super simple or small project to set up ANOVA functionality.
Well, no. I mean, look, we built this ANOVA stuff at a time when our ability to represent sort of named objects and things was much lower than it is today with associations and data sets and so on.
Right.
Question, if we were going to invent ANOVA in the land of data sets, would we be able to make an ANOVA data set from a data set, so to speak? Does that make sense? Is that concept a reasonable one? Eduardo, Gosha, please. Gosha, you're still muted.
I don't know.
I mean, I don't know.
How do we, what is our current ANOVA? I mean, right now we have only this package. Is that correct? Or do we have another way to generate ANOVAs? Okay, so I'm going to make the hypothesis that if you gave this ANOVA table as a data set with named, string names for these things, that will be useful. Do you see what I'm saying?
Yeah, like it'll be pretty, I guess.
No. I'm look, the whole point is, how do you use the elements here? Do you get what I'm saying? They're very hard to use here. I don't even know what the structure is. Do you know what it is? Do you understand my question? By the way, but that's a bug. Somebody needs to note that doesn't show preview there.
I got that.
Okay, okay. Do you know about this function? Gosha, Eduardo, either of you know about this function? Are you muted or are you, I don't understand. Are you here? Are you not here? Can you respond to that question, please?
I'm here, but I'm having a connection issues and I didn't correctly understand what you were asking.
Okay.
Sorry,
right.
I was also having connection issues and I just came back.
Sorry.
Okay. All right. Well, that explains why you weren't here. Otherwise, okay. Okay. I'm asking this function. Do you understand this function? What is this object? What is this output, for example? Okay. Look, if you have a connection problem, we can't continue this right now. We have to do it another time. Can you hear me or not?
Yes.
Okay, so are you going to respond or not? I mean, I'm trying to.
I have really hard time right now.
Okay, fine. All right. Okay, so let's pick this up another time. Okay, so this looks like some crazy stuff.
Yeah,
here.
I think it's table form or something under the hood. It's not.
Right. So what I'm saying is, you guys should think about, and next time come back with a proposal that it involves an ANOVA function that returns a data set. Okay. I think if you guys are, if the statistics team is unconnected, so to speak, let's not go over these other things right now. We're going to run out of time anyway. So let's move to these other topics and we'll bring those back. Okay, until.
Yep. So until is a variant of while that we talked about earlier in the year. We have an implementation of it. We just have documentation we wanted to review before.
Okay, evaluates body, then test. Until test first gives true. Why do we need that one argument form? Is that a good idea, or should we just leave that out?
It just follows what while does. It's in while, so we imitated it.
Okay. I don't know. Is it a good idea? It's not obvious that's a good idea.
It is not compulsory. It's just, again, it's just consistency with while.
Okay, this looks okay to me. Anybody object to this?
No.
No.
Okay.
Yeah.
All right. I don't want to take this right now because this is, unless there's an easy way to discuss this. What is this?
So this is an example. I talked to Andrew Yule, who's one of our customers who watched one of our previous discussions about having a general way to generate operator applied or to quickly generate operator forms. And he mentioned this is effectively like
but why isn't the star at star? Isn't this at star? What is this doing? I don't understand what this does. What does this mean?
Yeah, so this is this is feeding range into the first argument of list plot.
Oh, that's a different.
It's at star plus operator applied or something.
Right.
No, it's even more than that. It's even weirder. Never mind.
I
Because
think
it's
that's
taking
totally
apart the
weird.
arguments of list log plot.
Because this thing here has to not evaluate. It's going to get really weird.
Right. It's complicated to implement. I mean, that's why this example has a hold rest in there, because we don't want the list log plot evaluating and giving.
I think this is a lot easier if the code doesn't mean anything. We can look at this again, but I'm not optimistic. Let's look at this, which I think is a rather straightforward idea.
I mean, maybe the real thing would be to have some sort of syntax for operator applied, although I'm not sure that,
Not sure it deserves it. I mean, I think that this notion of you've got a symbolic function and you're going to spray. I mean, I think it also relates actually to this thing here.
Right. These two discussions are kind of interrelated, but they've branched a bit.
Right. So, okay. So this is this form. So the only question is, given that people in the modern world, 33 years ago, 35 years ago, when we first designed function, well, 42 years ago, when I first designed the analog of this in SMP, which had some horrible misfeatures, lambdas were an extremely obscure idea. Now they're much better known. And so the question is purely a syntactic question. We have a form of function right now, which is this very beautiful thing, which I love using when, the only thing I don't like about it is that I have to parenthesize it so much. But I love this thing. I mean, I think in cases like nest, it's terrific. Okay, so the question is there a value in having something which is a lambda, something which is lambda of x, x squared, as yet another form for function? And I would argue it's not completely crazy to do that. Comments from people.
I like it. Another question with that form is, could you have a syntax for the 3-argument form of function similar to for all?
You mean the one with attributes and things?
Yeah. So in for all, you can say for all x, comma, and then have conditions on the x, which is a little different than specifying attributes, but maybe that could be like lambda x, comma, hold first.
Well, except that we're going to need, in this case here, we would definitely need a lambda x, comma, y here.
Or list xy, yeah.
Right. But I mean, this thing is going to have to be parenthesized in this case, isn't it? Christopher, what do you think of this?
I think it's interesting. I mean, the only complaint would maybe just be that, having yet another syntax for function could be confusing, and people won't know which one they should use.
Yeah, but some people will pick the one they like. I mean, and it does answer the question, are there lambdas? Yeah, Edmund is commenting, it's only worth doing another form if it solves parenthesis problems, if it solves another type of parenthesis problem. I partly agree with that, but for example, this form, I really love it for nest. It's just a very clear piece of code.
Actually, how does the fancy arrow notation work with rule? Like, what's the precedence?
Yeah, that's a good question. I actually don't know.
No.
Not well.
Hmm.
I mean, I think we were pretty constrained in the precedence for this thing. It's not obvious that that is a bad way to write something. I mean, I understand it has to be parenthesized, but it's a little less obscure to have to parenthesize that than to have to parenthesize the thing with the ampersand. It's much less obvious. In this case, it's kind of obvious you might have to parenthesize. In the case C arrow A plus hash ampersand, it's much less obvious that would have to be parenthesized. I mean, that feels like a much more superfluous parenthesization. But okay, so maybe we can study what the precedence of Lambda could be.
Okay, yeah, that's something Itai had made a bit of a mention of, but he's not here today.
Sorry, who?
Itai.
Okay.
Another question would be if there's an askification of it.
Yes, that is a good question. What would its askified form be? It would have to be some horrifying, thing like that.
Yeah. I guess it looks like a bit like an uppercase lambda.
It does. What do there's some other languages that have some
Haskell just uses a backslash.
That's more horrifying than one could possibly imagine. I mean, could we in fact use this?
I'm not sure we have the right people here to say for certain.
I mean, what if you're dividing by a special character? Isn't the ASCII form of special character start with the...
Yeah, like a new line, for example. But I don't think you can have a new line in... See, it's not...
It's true. Having backslash means something, could lead to immense confusion.
Well, okay. So, I mean, it would have to be some kind of...
But like the ASCIification of all of our special characters is backslash open bracket, right?
Yes.
Right. So, and you can assign those values and then divide things by them. And
right. I mean, the problem is that a plain lambda, I mean, I guess plain pi means something. I'm not sure that it would break it. I mean, I don't think it would break anything to have plain lambda. Well, I don't know.
Well,
no, it would. It would. Never mind.
It
would. It just won't work because that thing as a pure symbol, is lambda as a pure symbol is something we absolutely have right now. So we can't use that. We can't use pure lambda.
Right.
So it would have to be a stylized lambda, which is okay. Which argues for an ASCIified form that can be sort of, like happens with this, which I like very much. I mean, that ASCIified form, which is vertical bar dash greater than, it's easy to remember. And, I don't know how people learn to type it, having seen just this. Well, perhaps we can think about this, okay? Think about the precedence and think about the ASCIification of it. I mean, it's a little bit less attractive to ASCIify it when it has to have subscripts. Because I don't think you can avoid the subscripts unless you have something like, lambda hash plus 1. Which, and I don't know, again, precedence is what we have to figure out. Is there a reasonable place where we can, for example, does this grab the hash plus one or not? I can't really imagine how it could grab the hash plus one. People comment on that?
Yeah, I'm not as familiar with like the match fix system and the other.
Okay, we have to
precedents and
look up
diphthic,
precedents.
but yeah. Mhm.
All right, I think it's time to wrap up here. Great. All right. Well, thanks everybody for everything, and talk to you all soon.